Okay, now let's look at one more example. And this time, we have the angle 1400 degrees. Kind of big. So now, we first find an integer such that, okay, so we find an integer k such that 1400 minus 360 degrees times k bigger than 0. Okay, you may also use the plus, doesn't matter. Okay, now we solve this inequality for k. So we have the 140 degrees, 1400 degrees greater than 360 degrees times k, and we divide both sides by 360 degrees. Then we get the k is less than 1400 over 360, and this is approximately equal to 3.89. So now we need to find the biggest integer which satisfies this inequality. Okay, so the biggest integer which satisfies this inequality is 3. So we may just let k equal to 3. Then you plug in this k back into this measure of the angle which is coterminal with this given angle. So you have the 1400 degrees minus 360 degrees times 3, and then you subtract, get 320 degrees. Now tell me which quadrant this angle is in. Which one? 4, right? In the quadrant 4, because 320 is bigger than 270 degrees, but less than 360 degrees, right? So it's quadrant 4. We may think 1 degree is too small, right? Compared to the common angles, 30 degrees, 45 degrees, 1 degree is very small. But if we use trigonometry in astronomy, 1 degree is too big. We have to use some smaller units. Okay, so we may divide 1 degree into 60 equal parts. The one part is called the 1 minute. So 1 degree is equal to 60 minutes. And we can further divide 1 minute into 60 equal parts. Then we get 60 seconds. So 1 minute is equal to 60 seconds. Okay, this is just like how we measure time, right? Then you can see 1 minute. Say we divide both. If we divide both sides by 60, then we get 1 over 60 degree. Right, 1 minute is equal to 1 over 60 degree. And we divide both sides by 60 in this equation, then we get 1 second is equal to 1 over 60 minute, right? And furthermore, we can also get 1 degree. This is equal to 60 times 60 seconds, right? That is equal to 36 100 seconds. Then 1 second is equal to 1 over 3600 degree. So before we just used the degrees, minutes, and seconds to measure an angle. So now with the calculators, and we may use the fractional part of an degree to measure an angle instead of using the minutes and seconds. But sometimes we have to do the conversion between the fractional degrees and the minutes and seconds. So now let's look at one example to see how we convert the angle to decimal degrees if we have the minutes and seconds. Let's go to the page 429 and let's look at the problem 34. Okay, here we have the angle 44 degree, 19 minutes, and 32 seconds. Now, we need to convert this angle to a decimal degrees. Okay, so this is the page 429, problem 34. We have the 44 degrees, 19 minutes, and 32 seconds. So first, we keep the degree part. So 44 degrees. And then we try to convert 19 minutes into degrees. We know 1 minute is equal to 1 over 60 degrees, right? So you have the 19 minute, then you may multiply this by 1 degree over 60 minutes. So actually 1 degree is same as the 60 minutes, right? You cancel that, you just get 1. So we do not change this value, right? But in this way, we change the unit, right? And similarly, 32 seconds, and we know 1 degree is equal to 3600 seconds, right? So you may multiply this guy by 1 degree divided by 3600 seconds. Then you do the conversion, okay, 44 degrees and plus this 90 over 60 degrees and plus 32 divided by 3600 and then degrees. Then you simplify and round to the 4 decimal places. Then you get the 44.3256 degrees. Okay, so this is how we convert a degree, minutes, and seconds to a decimal degrees. And sometimes we have the decimal degrees, and we need to convert this to degree, minutes, and seconds.